Okay, so now on to split terms that might have an odd number. And how do I do that? Oops, sorry there. How do I do that is, use decimals, fractions, and then multiply. Oh my. Here I have a combustion reaction where I have 3 carbons. So I need, oh, we're getting into odd numbers already. 3 carbons on that side. I have 6 hydrogens over here. So I'm going to put a 3 there. That's a 3, to make that 6 over there. So now let's look at my oxygens. I have 3 times 2, that's 6 oxygens there, and 3 there. So that gives me 9 oxygens total on the right side. So I need 9 over here. Well, what can I multiply 2 by to get 9? And the answer is, well, nothing. Well, at least not a whole number. I can multiply it by 4.5, right? If you put this in your calculator, 2 times 4.5, you're going to get 9. So 2 times 4.5 equals 9. So I'm going to put a 4.5 there. Okay, technically this is balanced, and if you were in college, we really wouldn't go any further because all we need out of a balanced reaction to do any math is the ratio. And you do have a 1 to 4.5 to 3 to 3 ratio. And if you know much about ratios, the next part really doesn't matter. But we want to make sure that it looks pretty. So how do I make all of these coefficients right here, these numbers in blue, how do I make them all so that they are whole numbers? And the answer is that you go in and you multiply everybody by 2 to make them whole numbers. So this is 2 times 1, and that's going to give me a 2. Oops, there you go, 2. 4.5 times 2 is going to give me 9. 3 times 2 is going to give me 6, and this is going to give me 6. So I have a 2 to 9 to 6 to 6 ratio. And if you were to double check, that's your balancing on both sides, you would see I have 6 carbons there, 6 carbons there, 12 hydrogens right here, and so I have 12 hydrogens right there, and then 9 times 2 is 18 oxygens, and then on this side I have 12 plus 6 oxygens, and that's also 18 oxygens, so that's balanced, and that's your ratio. All right, let's try another one. I've got 4 carbons over here, so I'm going to put at least a 4 there. 9 hydrogens. What can I put in front of that 2 to make it 9? 4.5. See, at this point, there's no point in continuing to add whole numbers until you get all the way up there. I mean, you could do it just like all of the other ones, but if you use fractions or decimals, this just makes it go by a little quicker. All right, so now I've got 9 hydrogens on both sides. Let's look at my oxygens. I've got 4 times 2, I've got 8 oxygens there, and 4.5 times 4.5 oxygens there. So this is 8, 9, 10, 11, 12. I've got 12.5 oxygens. What can I put there to give me 12.5 oxygens? And the answer is 6.25. Okay? So when I have a 1 to 6.25 to 4 to 4.5 ratio, all of my stuff is balanced. But I can't leave it like that. I have to go in and multiply everybody to get a whole number. This time, I just can't go in and multiply everybody by 2. I've got to do something else because if I multiply this guy by 2, I'm still at, 12.5. So I'm going to up that and multiply everybody by 4 because that will at least take care of this quarter part here, and let me see how that works. So if I go through and I multiply everybody by 4, I get 4 here, and then 6.25 times 4 is 25. 4 times 4 is 16, and 4 times 4.5 is 18, all right? getting kind of hard to see. So let me see if that works here. All right, so let's double check our carbons. 4 times 4 is 16. 16 times 1, technically there is 16 carbons. And so 9 hydrogens, so the hydrogens balance. I know the oxygens balance. Okay, so now this is balanced. And this is a big number. And guys, this is really about as hard as it's going to get. Okay, so I'm glad I'm doing one like this with you. So in this instance, I have a 4 to 25 to 16 to 18 ratio for that problem. All right, let's try one more. Here I have 10 carbons. Change my color. So I'm going to put a 10 there, giving me 10 carbons. 22 hydrogens, so I'm going to put an 11 there. And now let's work on those oxygens. I like how at least the oxygen is just right there. All right, so I've got 20 oxygens right there. 2 times 10 is 20, and 11 there. So 20 plus 11 gives me 31 oxygens on this side. So 2 times what is going to give me 31? Do you know? At this point, if you don't understand how to do that, you could also take 31 and divide it by 2, and that would give you your answer, right? Let's do some algebra. Let's divide by 2, divide by 2. That makes my question mark. It's going to equal 15.5. So 15.5. All right, I know I can't leave it like that, but the good news is that I'm at a 0.5, so I just want to multiply everybody by 2. 1 times 2 is 2. Keep doing that. 15.5 times 2 is 30. 31. 2 times 10 is 20, and 2 times 11 is 22. So I have a 2 to 31 to 20 to 22 ratio on that one. And this is just another one of those things where don't practice until you get it right. You practice until you cannot get it wrong.